Hey, student, how are you? Welcome to our session on conditional probability, the probability of A given B has occurred. Consider the following situation. A screening test for a disease has the following data. If a person actually has the disease, the test correctly shows a positive test result 97% of the time. If a person does not have the disease, the test still shows a positive test result 2% of the time, a false positive. And 1% of the people in the population actually have the disease. What is the probability a person actually has the disease given a positive test result? We'll answer this question at the end of our session. Let's take a look at a conceptual understanding of conditional probability. Given the following set of numbers, set A and set B, find the probability of A given B has occurred. We'll take a look at the Venn diagram to help us find this probability. Conditional probability given B has occurred. Given B is our denominator. If we look at our Venn diagram, we see we have 3 elements in set B. How many of those elements are also in set A? Probability of A given B has occurred. There are 2 overlapping elements, 3 and 5. So our probability is 2/3. Let's take a look at 2 practice problems. In a class of 40 students, 18 play basketball, 12 play soccer, and 6 play both sports. Let A B plays basketball and let B plays soccer. Find the probability of A given B, the probability a student plays basketball given they play soccer. Let's take a look. Given they play soccer. So plays soccer is our denominator. There are 12 students that play soccer. And then how many students who play soccer also play basketball? Meaning how many students play both sports? 6. So we get a 50% probability. Number 2. Consider the two-way table with students' preferred superpower and favorite food. Let A be invisibility and let B be tacos. Find the probability of A given B, and number 2, find the probability of B given A. Here we go. Number 1. Probability of A given B in this situation means the probability that a student chose their favorite superpower is invisibility, given their favorite food is tacos. So given tacos, we'll look at the row total. There are 100 students that prefer tacos. And then in the numerator, invisibility and tacos, there are 75 students whose favorite food is tacos and whose preferred superpower is invisibility. And we get 75% probability. Number 2, going the other way, what is the probability of B given A has occurred? Probability of tacos given invisibility. So we'll start with given invisibility, looking at the row column total, 135 students, preferred superpower is invisibility. And then tacos and invisibility is the same 75 students. We'll reduce, and we get about 56% probability. The conditional probability formula is probability of A given B has occurred is equal to the probability of both A and B occurring divided by the probability of B. Sometimes you'll see it with the intersection notation. Let's revisit practice problem number 1, and we'll actually use the formula. So when we were doing this problem, technically, we should have put the probability of playing both sports, basketball and soccer, in the top, and then the probability of B plays soccer in the denominator. And then you could divide the decimals and get 50%. Or you could divide the fractions, keep change flip. Either way, we do get 50%. Let's use this conditional probability formula and we'll answer the question about the screening test for the disease. Let's set up a tree diagram to help us solve this problem. We'll start, and first we have 1% of people actually have the disease. This means that 99% of the population does not. And then if you actually have the disease, the test will show a positive test result 97% of the time. That means 3% of the time it'll give you a negative even though you have the disease. That's a false negative. And then if you don't have the disease, the test still gives a positive test result 2% of the time, a false positive. And 98% of the time you'll get a negative test result. Let's use our tree diagram to answer this question. What is the probability a person actually has the disease given a positive test result? So the probability of A and B divided by the probability of B in this situation means the probability you actually have the disease and a positive test result divided by the probability you get a positive test result. We'll use our tree diagram. Starting, 1% actually have the disease times and 97% of the time you get a positive test result. And then on the bottom, we can get a positive test result, the same branch that we followed, 1% has the disease, 97% positive test result, or addition, you don't have the disease and get a positive test result, 99% times 2%. So we'll add, because that is another situation in which we could get a positive test result. We'll find the decimals for the numerator and denominator and divide. Wow, there's only a 33% chance that you actually have the disease given a positive test result. And that concludes conditional probability. Thanks so much for joining our session, and I'll see you next time.